I am asking you to find f of x if f double prime of x is 12x squared plus 6x minus 4. F of 0 equals 4 and f of 1 equals 1. So we are on f double prime. That means that is the second derivative. So we have to do the antiderivative twice. So the antiderivative of f double prime would just be f prime. Okay, so remember the 12 just stays. You add 1 to the power and you put the reciprocal in front. You can go ahead and combine those if you want. I probably will in the next example. Antiderivative of x would be 1/2 x squared times our 6 minus the antiderivative of 4. And what do we need on the end?
Plus 2.
So what I have is my antiderivative is 4x cubed plus 3x squared minus 4x plus c. And how could you always check those?
Redo the derivative.
Do the derivative and see if you get it back. Okay. But I'm giving you some more information. However, the information I'm giving you applies to the original function. So what do we need to do at this point? Okay. So there's my first derivative. So if I want the function itself, we do the antiderivative of that. So what's the antiderivative of 4x cubed?
1/4 x to the 4th.
Okay. So the 4 stays 1/4 x to the 4th, or you could go ahead and multiply them if you wanted. 3 times the antiderivative of x squared
1/3 x.
minus 4 times the antiderivative of x
4 is the 1/2 x squared.
plus, what's the antiderivative of c?
C squared.
That's c squared, because c is representing constant, so it might be like a 5.
CC.
CX.
It would get the x put back with it.
Oh, okay.
Plus, we would have a new constant, right? Now, I don't want to call it c again, because that would imply that they're the same numbers. Would they have to be?
D.
I usually go with k's, but if you wanted to do d, you could.
I was just going on the list.
Yeah, I was going down the rest of the alphabet. I don't know.
So we have x to the 4th plus x cubed minus 2x squared plus c times x plus k. Now if I do the derivative of this, twice, I get back to my original function. But when I give you this information, I am asking you to find out what c and k are. Find the exact values of those. So when I say f of 0 equals 4, f of 0, if you put in 0 for all of your x's,
K is 4.
you get 0 plus 0 minus 2 times 0 plus c times 0 plus k. So that's just k. And I told you that f of 0 is equal to 4. So what I currently know is that my k is 4. Does everyone understand how I got that part?
Mm-hmm.
So at this point, my function is x to the 4th plus x cubed minus 2x squared plus c times x plus 4. But now, I also know f of 1 is equal to 1. Alright, so if I put in 1, and that has to equal 1. So we get 2 minus 2, so that's gone. So c plus 4 equals 1. So c is,
X.
so our total function so we created a function that met all of these requirements.
How much work do you want us to show for all this?
I showed everything. You probably don't have to show quite that
I
much.
was just saying, because like we can reason.
I'm okay with that. Just don't mess up.
Oh, I won't. I'm laughing.
Initial value problem.
Alright, so if I give you any point from the original function, that would allow you to find the values of the constants in your original. So sometimes we can find them and sometimes we can't. Any questions there?
Why did you not do that with your
Because I wanted everything to cancel out. If you'd done the f of 1 first, you would have ended with c plus k equals 1, so we wouldn't get the actual answer yet. So, process of elimination, if you do one and you still have 2 variables left, try putting in the other 2 first. The zeros are usually the nicer ones to plug in. Other questions? So if I give you this one, solve the initial value problem. That means find the original equation. We could rewrite this. X to the 4th minus 3x. How would I write 3 over x cubed?
3x to the negative 3.
So if I do my antiderivative, that would be my original function. Antiderivative of x to the 4th.
1 fifth x to the 5th.
Antiderivative of 3x.
1 half x squared.
Plus 3 times antiderivative of x to the negative 3.
Negative 1 half x negative 2.
Right, when you add your power is negative 2, so the negative 1 half in front, and then we need so here's my function. Now if I want you to find k, or sorry, find c, we are going to plug in f of 1 equals negative 1. So when I put in 1 for all of my x's, 1/5 minus 3 halves plus c, it has to equal negative 1.
Oh, yeah, I didn't see that part.
And so if I combine 1/5 minus 3 halves minus 3 halves, I'm assuming you guys are checking my work, that should be negative 14/5.
Oh, I got 16 fifths.
I'm negative 14 fifths.
I just
Right.
did minus 3 half together, and then it was 3,
Mm-hmm.
and then I moved it over.
If I'm wrong, I believe everyone else.
Yeah, no, Miss
Yep,
Eccles
Miss
right.
Eccles is right.
Okay.
Yeah,
15.
because if you add it over,
You just
it's
did a negative 1/5.
9/5, which is.
Probably.
So then if we add that over, so it'd be like negative 5 over 5 plus 14 over 5. So c is 9/5.
Oh, yeah.
So our actual function.
I almost like these as much as the derivatives.
I enjoy these.
They're like little brain teasers. What? What does that even mean?
You seem like a very person.
I did one today in the library, yeah.
You said a Wordle?
Yeah.
I was gonna do it today, and then Coach Kirby got mad at Dylan for doing it in class and told everyone the answer. So
Yeah.
Oh, don't tell me. So you do the word as well? Ooh.
Alright, are we good on this one?
It's funny because it's gold.
Okay, so here is the graph of a function. I want to graph the antiderivative. And I am telling you that f of 0 equals 2. So what is that?
When the x is 0, what is y?
So when x is 0, y is 2.
How do we know the reference? Like, is that one is it? Or wait, I guess it doesn't really matter, does it? I was just saying because it doesn't give us like ones and twos for the
Oh.
original.
Yeah, you just have to kind of
You get to pick.
budget there. Okay, so we are used to looking at a function and graphing the derivative. Now we have to if the function is increasing, the derivative is
Decreasing.
So if
Positive.
positive.
No, I don't know what I
If
thought.
the function is increasing, the derivative would be positive. If the function were decreasing, the derivative is negative. So if we're looking at the derivative, here the derivative is negative, so that means the function was
Decreasing.
decreasing, because it would have a negative slope, so it has to start off decreasing. Okay, right here, the derivative was 0. What does that tell us?
it's 0.
No.
No, it was a max or a min.
Yep.
So it's decreasing, and then it has to hit a max or min. And then the derivative was positive, so that means the function is increasing.
Oh, we're not saying that it hit that line at 0.
Yeah, you're drawing one possible graph. There are lots of.
So could it hit that 0 then?
I mean, could it come all the way down
Yes.
here? It could, but it doesn't have to.
Okay, but that's where I drew, so.
Now right here, my derivative was 0. So what does that tell me about my graph?
Another
Another max or min.
Mm-hmm. So maybe we have a max right there. If you want to get really precise, we could talk about concavity.
No,
but
thank you.
we
It's
don't
okay.
have to do that quite yet. Okay, then my graph, the derivative stays negative. So what does that tell us?
Decreasing.
It's decreasing the whole time. Now it is kind of flattening out. So it's decreasing, but it's going to kind of have a horizontal asymptote there.
Oh,
It's still
goodness.
decreasing, but not very quickly.
Wow, this is lovely.
That's like the same graph, but you flipped it over and you flipped it on the x and y axis.
Wait, is that actually the truth?
No.
No, I.
Oh, well,
Sorry, Chris.
thought we had the strat.
All right. So
Maybe
it's kind of making us think about our connections here. Another connection we want to make. We've talked about motion problems a lot, right? Position, velocity, acceleration. So remember, your original function is your position. When we do the derivative, that gives us,
Velocity.
and the second derivative is,
Acceleration.
Will we ever do jerk in this class?
I mean, we talked about it, but it's not one that we commonly find. I just told you that's what it would be.
So there's not really any application for it?
Not in Calc 1,
Who uses jerk?
Oh,
What field?
like physics.
Person, what flavor is your water?
Green monster.
Okay.
Alright. Why don't you guys try this one for a second? Let's see if you can think about it.
Whoa.
Look at the two of them.
Okay, so we're looking for position. So A represents acceleration, which we know is the second derivative. So the antiderivative of acceleration would be velocity. So that would give me a 10t minus 15t squared plus c.
Mhm.
Yeah.
And I told you that v of 0 equals 5. So if I put in 0 for all my t's, I get c, which is negative 5. So my actual velocity is 10t minus 15t squared minus 5.
Do you want us to write out our actual velocity? Like if I wrote out my actual position?
I don't care. Then, what do we have to do?
Derivative again. Or antiderivative, rather.
The antiderivative of velocity is position. So the antiderivative of 10t, so you would make it t squared times a half, so 5t squared. Okay, this becomes t cubed, so 15 times 1/3 is 5. Do I confuse you when I do it in one step like that?
No wonder.
Antiderivative of 5 would be
5t.
plus a new constant. But I know that x
Why
of
didn't you include your... Oh, you did. Never mind.
if I put in 0 for all my x's, that just gives me k, which has to be 5. So our position. I have 5t squared minus 5t cubed, or if you flip it around, negative 5t cubed plus 5t squared. Minus 5t. I did notice a couple people that had a plus 5t there, so watch your sign. Plus 5.
No. I know why I did get a head nod. I I like integrated X's into my problem for
Just-
the T's.
You didn't have enough variables as it was. We just needed a few more.
Yeah, no, I just wanted more.
Just more of a challenge.
Yeah.
You need to get that safety net.
Time to do grouping,
Hey, that's a lot of problems on the board.
and now we can solve.
All right. Any questions on that one?
No, I'm pretty good.
Let's take a look at this one. A particle starts from rest at the point x equals 10 and moves along the x-axis with an acceleration of 12t. Find the position function. Okay, so I know my acceleration. If I want to get to position, what do we have to do?
Double antiderivative.
Okay, so the antiderivative of acceleration would be velocity. So that would be a 6t squared plus c. Now we want to see if I gave you any information to find c. And I actually did. I said it starts from rest. So your velocity at time 0 is what?
0.
0. If you're starting at rest, your velocity is 0. So if you plug that in, c is 0, so the velocity function is just 6t squared. So now if I want position, antiderivative of 6t squared would be
2t cubed plus k.
do I have any information to find k?
It's 0, it equals 10.
The point x equals 10. So my beginning position is 10. So I plug in 0 for my t, I just get k, which is 10. So the position function is 2t cubed plus 10.
Did that mean that? Oh, I understand it now. Yep,
I'm glad I could clear that up for you.
thank you.
Anytime. I can stand here and smile while
Well, Carson works
reason
through his
through it
problem.
yourself. Alright, I want you guys to try the next one.
Directing.
Yes.
Alright.
Kills
Yes.
the whole thing.
Yes.
It's a cat.
Yeah, that's low-key so scary. That can actually like happen.
So, initial velocity was -6. So our velocity is the antiderivative. So that's 3t squared plus 4t plus a constant. But if you plug in 0, we know we have to get -6. So the constant was -6. Did you guys get that part? Okay, and then we need to get to position. This time it used s for position instead of x. That means the same thing. So that would be t cubed plus 2t squared minus 6t plus k. But I'm telling you s of 0 is 9. So if you plug in 0, you get 9. So that means the k is actually 9.
You don't want to rewrite that one.
I know. Getting lazy. Here we go.
Are
Did you
you-
get it?
Yeah. Are you okay if instead of using S or X, I put P of T?
Yeah, as long as I know what you're talking about.
That's
All right. I think I have more word problems on here, but I actually think I'm going to wait. We're going to do some more like those in a later section, when it will probably make a little more sense. So I am going to take problem 69 off. We did 1 through 17 Friday. I don't know why I wrote 23 through 27 odd instead of just 23, 25, 27, but there you go.